Have you ever thought about how your brain starts and stops movement? Well, you can thank your basal ganglia for that. The basal ganglia are a collection of the deep brain nuclei. The main players include the striatum, the globus pallidus internus, and the globus pallidus externus, which is referred to as the GPI and the GPE, respectively. And there's also the subthalamic nucleus and the substantia nigra. The substantia nigra releases dopamine, which will come in handy later, and is located within the midbrain. There is also another structure called the thalamus. All of these structures work together to make up the direct and indirect pathways of the brain, which relies on a concept called disinhibition, which is the inhibiting of an inhibitor to free the next structure, which sounds really weird, so we're going to work together on it play by play. The direct pathway starts with the cortex sending an excitatory neurotransmitter called glutamate towards the striatum. The striatum is going to send GABA, an inhibitory neurotransmitter, towards the GPI, and the GPI is actually tonically inhibiting the thalamus, which means that once the GPI is inhibited, it can disinhibit from the thalamus, releasing it, allowing the thalamus to send glutamate towards the cortex, which excites movement. Now, if you're both a neuro fan and a softball fan, you're in luck because we're going to the softball field.
Now picture this. Our cortex is actually the batter. Our batter is going to hit a green glutamate ball towards our striatum or our shortstop. Striatum is going to throw a red GABA ball towards our GPI. This is going to inhibit our GPI and force her to go back to her position. This allows our pitcher, our thalamus, to excite the cortex by throwing a green glutamate ball. With this hit, we have voluntary movement. Now, how does the stopping of movement or the indirect pathway work? The cortex is going to do the exact same thing it did in the direct pathway, hit towards the striatum. This time, our shortstop's going to throw a red GABA ball to our third baseman, our GPE. Umpire, or our subthalamic nucleus, calls out. That's going to excite our second baseman, or our GPI. GPI really excited. This is going to lead the GPI out of position, not letting the pitcher pitch, or our thalamus excite the cortex. This leads to the stopping of the voluntary movement. You may have noticed that the striatum is a part of a lot of decision-making in the movement process, which is very similar to a shortstop. So what's telling the striatum where to go and the shortstop where to throw? That's dopamine. Now let's use dopamine as a runner. Let's say we have one runner on first base. This activates the D1 receptors on the striatum. You see what I did there? This leads us to our direct pathway being activated with the force at second base. Starting the voluntary movement. There are two runners on two bases activating the D2 receptors from the striatum. So our force our cortex is going to be hitting toward the striatum. And from there, our indirect pathway is activated.
And just like that, your basal ganglia keeps you moving, one pitch, one throw, and one hit at a time.